Everyone, thank you for being here today. I know we're getting into the busy swim season, and our industry folks are running 90-0, as well as our public health officials. But thank you for carving some time out to be here. And in advance, thank you to our presenters for carving time out to be here. Today, we're going to talk about chemical safety. Chemical safety is an ongoing concern. With every year, we see a significant number of injuries, pool chemical related injuries, both to staff and bathers. So that's what today is about, right? So we're going to talk about chemical safety from three different aspects, from a control standpoint, from a storage and construction standpoint, and finally from the human standpoint. I'd like to introduce our presenters today. So first we have Bob Kappel with Prominent Fluid Controls. He will be our controller expert for today. We also have Stephan Seliskar from Counsilman-Hunsaker, as well as Lloyd Munn from Cadence Insurance. We have a wonderful panel full of experts, and we're very, very excited that they're here and participating. So we're going to get started. If you have any questions, please put them into chat. We're going to present for around 45 minutes and then have another 10 to 15 minutes of Q&A. So with that being said, we're going to turn it over to our first presenter, Bob Kappel. Okay, Bob, the floor is yours.
Thank you, Dewey. I appreciate it. And good morning, everybody. Thank you for taking some time out of your busy day and joining us here. We have quite a bit to talk about and quite a few important things to relate with you. So the purpose for our visit today is I want to talk a little bit about how a chemical controller, chemical pool water controller can be used to enhance safety at a facility. There's a lot of things that are built into the controllers nowadays that can enhance various aspects of managing your risk at a facility, and some of them are super critical. So we'll be covering those today. Next slide, Dewey. Thank you. So one of the things that I like to do first is kind of establish a base of where we're at. A lot of people have a pretty good feel. I'm sure everybody here that operates a swimming pool also has a controller on their pool. There's no public pools that are being hand dosed that I'm aware of right now at the Class A level pools. But just to reinforce, chemical controllers help us monitor and control pH, ORP, ppm, temperature. They can do conductivity. They can monitor flow. They can monitor flow rate. They can monitor pressures and vacuums. They can monitor chemical inventory levels. They can measure turbidity. And they also can take in and enunciate outboard equipment alarms. Next slide, please. We can also control a lot of outboard equipment, and obviously the chemical feeders, the chlorine feeders, the acid feeders for pH management, CO2 feeders, taking care of some of the more modern sodium hypoventuri feed systems, dry chlorine feeders, dry acid heaters, anything that you can think of that lies outside, that's with the pool but is outboard of the controller itself. Most controllers nowadays can take a signal in and then do something with that signal to either enhance performance or enhance safety. Next slide, please, Dewey. I want to get my timer going here so I can be respectful of everybody's time. So they're innate in most controllers nowadays. It can recognize a low or high ppm and enunciate that in some way, whether that takes the form of an audible alarm, a light, a flashing light on the control panel of the controller, can email, can text out. So these are all enhancements and all things that unique things you can do with the chemical controller. Instead of just hanging it on the wall and watching the front of it, we can get some useful information to enhance the safety and performance of your facility. Well, high and low pH, low chemical inventory levels. One of the things that's being done nowadays that's pretty exciting is that chemical inventory levels can be measured, and then alerts can be sent not only to the operator, but to the service providers to go ahead and have them come to your facility and fill the crocks up, or the chemical storage bulk tanks. One of the things that we get frequently is that, you know, your controller is not working. We'll get that phone call into our company and we ask them, well, how's your acid level? How's your chlorine level? Oh, they're fine, when actually they're not. They're empty, and the pickup tube for the pump is out in the air, and so the system can't pump. So this is an automated system to ensure that we're not having any peaks and valleys in your chemical feed strategy, and which may lead to low chlorine levels, which is a danger for people in the pool, or high levels. We can monitor and check for no flow or low flow. There's overrun timers that are on a lot of controllers nowadays, which means that if the chemical controller perceives that the pumps have been on too long and they're not seeing a change within a given time period, that the controller will go ahead and kick an alarm and alert you that, hey, the system's been trying to make set point, but it can't. It's been 4 hours, it's been 2 hours, whatever you enter into the controller as that threshold, and then you can get an alert that the system is not keeping up, it's not feeding. And quite typically, like I mentioned just a couple moments ago, is that this is due to inadequate chemical inventory levels. There's a manual on timer that's available in some controllers. Some of the controllers have a prime function, which allows you to prime a pump. And what this does is sets a threshold, let's call it 30 minutes, 20 minutes, 10 minutes, whatever you designate. And if you put it into the manual position and just let that pump feed in order to prime the pump or to get some additional chemical into the water, if it surpasses that threshold that you've set, it'll go ahead and go back to automatic instead of staying on. I did this one time a long time ago in my service career, where I left the facility on Friday afternoon, and I left the chemical feeders in manual, the controller in manual position. I drove 2 hours home and realized that I had done that. I had to turn around and come back. And in the meantime, the pools had overfed and I had to manage that. Outboard equipment, warnings and alarms. If there's a low UV in the water, the UV system is not functioning, an ozone system isn't functioning, chemical feeder is locked out for some reason, the controllers nowadays can go ahead and take that signal in and then go ahead and also kick an alarm, warning people that, hey, we have a problem. And the whole gist behind this is to take data in, parse it, make it important to us, and then go ahead and enunciate that in a way that you can stay current and alert on the conditions in the swimming pool. You can hook up visual alarm lights. I've noticed a lot of facilities are putting a small light outside the equipment door so that they don't even have to be in the mechanical room to realize there's an issue, and then a light goes on and people know there's a condition that needs to be addressed. There's audible alarms, and excuse me for this spelling error, I always have to have one on every PowerPoint I do. So there's data logging events, which is really important, because what the data log does is give us an electronic record that cannot be changed of the conditions in the swimming pool. It can log if who's getting into the controller, if you have password protection on the controllers, and it can, everybody has a unique password. You can see who's in the controller. You can see what time somebody made changes. You can make sure that your chemical levels in the pools are being recorded electronically and not only manually, so that you have dual documentation for this. And a lot of facilities nowadays are keeping this electronic record in addition to the paper record, as just an additional risk management strategy. If anybody were to call in the question chemical levels on a certain day at a certain time, you have that electronic record to go back to. The other thing that's very useful on a lot of controllers nowadays is the ability for these controllers to graph. So what you can do with these graphing techniques is look for trends, either high performance or low performance trends, in your facility, and you can actually start to tweak the way the chemicals are injected into the water in order to make sure that you don't have peaks and valleys, that the controls in the pool for chlorine and pH levels is very flat and maybe very low swings. And that can help you diagnose a problem with the water, diagnose a problem with the equipment, or you can just be reassured that the system is performing as you want it to. Next slide, please. Now we're gonna dive into actual safeties, actual mechanisms that are innate in the pool equipment to help prevent chemical feeds at times when you don't want that chemical to feed. Intrinsically in most flow cells nowadays, and this is a good smattering of what's out there, is we have a lot of different looks or configurations for the flow cells across the board by different manufacturers. Next slide, please. Within those controllers and supplied with, I think nowadays, almost every controller that's sold is a flow cell safety switch. So we have water passing into a flow cell. That is what the sensors use to sample the water, the pH, chlorine level, ORP, temperature. And built into those cells are usually one of these two switches. One is a rotary flow switch, which is the one that you see on the right here with the paddle wheel on the inside. And then the other style on the left is a float switch. And you can see on the right, on the left-hand cell, there's a small gray float that's in there that'll float with the water flow, and then it's a magnetic switch. So this is a positive flow indicator so that you're checking to make sure that the system actually has water flowing through it. Next slide, please. There's other safeties out there. These are redundant safety flow switches. Now, one of the things I want to make sure that I comment on, and this is, I think in modern times, this is the most critical aspect for your pool operation. When there's a chemical accident, quite frequently, and more frequently than any other reason, is when there's no flow through the system and the acid and the chlorine are pumped together into a pipe space where there's no water movement, and that high concentration of chlorine and the high concentration of acid forms chlorine gas. In that space, then there becomes a gas bubble because the gas displaces the water, and chlorine, there's this chlorine gas plug in the system. And quite frequently, somebody will realize that there's no flow through the system, whether somebody forgot to turn the pump on, whether somebody, there's something wrong with the system and the pump's not actually pumping even though the motor's on. There could be a whole host, somebody left the valve closed. These safeties are designed to make sure that there's always water flow when there's chemicals being dosed into the pool. Please, 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 as a matter of routine, and I would recommend every single day, along with your wet tests that you take, that you're going to go ahead and test to make sure that these safeties are functional. You log it and you make it part of your permanent record that you have tested these safeties. There are multiple accidents per year due to chlorine gas release into the pool because of this reason. A lot of times it's because the flow switch is either stuck. Dewey, can we go back one slide, please? So on the rotary flow switch here, it's possible to get debris in there that prevents that wheel from spinning. That's going to go ahead and kick an alarm. But there have been cases when the switch has failed, or the switch is moving just enough through, maybe there's a vacuum being pulled in the pool where the rotary flow switch is turning just enough in order to allow the chemicals to feed. Because these switches send a signal to the controller and tell it, is it okay to feed or is it not okay to feed? In the case of the float switch here, it's possible for debris to get in there and to make that float stick at the high point when it's making contact with the magnetic sensor. And it also falsely indicates to the controller that we have flow through the system. In all cases, we always recommend to put a Y strainer in front of this to catch any debris. that may be in the system, even post filter. And we always recommend to have our flow cells installed post filter. So we're basically double filtering to make sure that we're keeping as much debris out of here as possible. But if you have a broken lateral, it's very possible for sand to get in here and cause these switches to malfunction. We can go next slide, please. These are redundant. Go back one. Thank you. So here's a redundant safety, and we always recommend redundant safeties to the primary safety that's on the controller. Safeties will fail. Safeties need to be tested. They need to be maintained. They're not just set and forget. It's critical for risk management to keep people safe and to keep your risks managed by paying attention to these items that a whole lot of people don't pay attention to. I've been to facilities where big facilities with thousands of people moving through there on weekends, where I've seen the flow cell safeties bypassed. There's a wire, a jumper put in, and it's extremely irresponsible to have that happen. We also recommend, like I was mentioning, the redundant safeties here, where we can also monitor positive flow through the system, whether we use the flow sensor that's measuring the GPM flowing through the system, take a signal off of that and use that as an additional mechanism to give us assurance and give the controller a signal saying that, yes, there's positive flow moving through the system. Same thing with the paddle sensor. This can go in a return line, and just like a stream, and you can just think of the water flowing past here, pushing on the paddle and closing that switch. And another way that we can positively indicate that we have good flow through the system. Next slide, please. So there's other potential safeties out there, and I've seen a lot of pool designers put in things like interlocks so that you're running the controller signal or the power for the pump or the feed devices through an auxiliary on the motor starter. So a lot of the big pumps have a separate starter on the wall where you're throwing a switch, pushing a button, contactors come together. Well, there's a smaller one off to the side that closes along with that. And that's a way we can stop chemical feed by killing the power to the feed device. I've seen a ton of incidences where the main power to the chemical controller is interlocked through the pump starter. We do not recommend this. Two reasons. One, I've seen pump starters chattering, and there's nothing more. Just think about your home computer. If you were to turn that on and off repeatedly 60 times a minute, eventually you're going to fry it. That's what happens with controllers too, because they're microprocessed nowadays. The other reason why not to kill it is if you kill the power to the controller, you just turned off your eyes and ears in that pump room, and you have no awareness remotely of what's happening in the system. You can't get any emails, you can't get any alarms. The controller can't send out anything because there's no power going to it. And so I think that's really a bad strategy, because like I said, you're taking away your eyes and ears in the pump room. Also, if you're using a VFD, there's built-in characteristics, there's built-in digital inputs and outputs that you can utilize in the VFD to run signals through to let the controller know that the VFD has been turned off, and therefore we're going to lock out any chemical feed. The whole basis behind everything I'm talking about is to make sure that the chemical controller has good information to make good choices about when the chemical feed events should occur. Next slide. And again, just a few examples I pulled up when I was making this slide. Safeties must be tested on a regular basis. And if there's anything you do, please do this. Please start doing this. Please make this a part of your regular routine, and then log the results. And if it's not functional, get it fixed as fast as you possibly can. Next slide. So again, I'm going to move through this a little bit quick because I'm approaching 15 minutes right now. This is a typical controller interface to see the different types of readings you can get off of a controller remotely, whether it be off of a mobile device or it's off your computer. And then the alarms can be enunciated here. And again, the controllers can go ahead, and if it's connected to the internet via either cellular technology or the building local area network, get access to the internet, and then it can go ahead and clear and send out alarms, parse that information, and get you really super useful information to keep your facility safe. Next slide. And again, just a quick look at the graph capabilities of some controllers. Next slide. And we're going to skip the future trends here because I'm bumping up. Dewey, if you can go to the last slide, please. So again, if there's any message that you take out of today's seminar with what I'm presenting, it's to make sure you have safeties, consider redundant safeties, and also make sure that you're testing your safeties to make sure that you can prove that they're functional. So thank you for your time.
Great. Thank you so much, Bob. As a reminder, you can put your questions into chat and we will answer those towards the end of the webinar. And certainly Bob will be available to help answer those. Next speaker is Stephan Seliskar with Counsilman-Hunsaker. Stephan, thank you for being here. The floor is yours.
Thanks, Dewey. Hi, everyone. My name is Stephan Seliskar. I'm a project manager with Counsilman-Hunsaker out of our Dallas office, and I'm going to be getting into some design considerations and concerns that we look at when designing chemical storage spaces or rooms that house chemical treatment room systems. So, Dewey, if you could go to the next slide, please. Two of the biggest things that we get into when designing a mechanical space and spaces that operators and staff members will work out of are ease of use and safety. So I talk about how safe environments aren't sexy. I bring up that point to sort of wake up people who might not be paying full attention, but also speak to the fact that these chemical treatment rooms are designed to be as bulletproof as possible. We want to, take the tried and tested approach. We don't want to reinvent the wheel. Make sure these spaces are as robust as possible to ensure their longevity and the safety of the operators. We want to prioritize isolating the chemical treatment systems at all costs. So I'll talk about some of those options here coming up, but we want to make sure that those spaces are isolated from the main mechanical space and the rest of the building to prevent cross-contamination of any hazardous or caustic chemicals and chemically laden air. It's impossible to completely eliminate the possibility of human error, but we want to design these spaces to be as limited as possible in the sense that we want them to be driven by the water chemistry controllers that Bob just discussed, and not necessarily relying on a ton of human intervention. We want to set their control parameters and let them do their thing. So that will in turn minimize the time spent in these chemically laden air spaces by your operations staff, by an operator themselves. So Dewey, if you can go into the next slide. So there's a couple things that we can look at when designing these spaces. So one, chemical treatment rooms, if we can get them, are supposed to be facing the exterior of the building. We want to make sure that they are only accessed from a storage drive or some sort of sidewalk that goes around the perimeter of the building, because we don't want any caustic fumes leaching into the main mechanical equipment room or the natatorium or whatever space might be adjacent to your pools. So there's a couple ways that you can help to reduce the corrosion and deterioration of those doors. So exterior doors should be 316L stainless steel or galvanized stainless steel with epoxy paint. It can sometimes get to be expensive, but it's well worth the cost when you look at replacing those doors. several times in, over the lifetime of your facility. Ideally, those doors include louvers to, sort of drain any type of any air that would be in the space. And I'm going to talk about the mechanical ventilation of the spaces here in a little bit, but those doors should include louvers. And we, by placing the doors on the exterior of the building, we're preventing cross-contamination or, corrosive fumes from leaching out into the surrounding areas. A lot of what we do is to design around, the intent that we want these systems to be as durable as possible. So we found that dual-headed chemical feed pumps tend to fail more often than their single-headed counterparts. So if you look at a typical Stenner pump, we'd want to design around maybe 45 MP3s, multiple of those pumps, as opposed to a larger 85 series pump to prevent the deterioration of the pump. Not only that, but we also have the ability to store a lot of those single-headed pumps on the shelf so they can be swapped out a little bit easier. Again, thinking about how can we minimize the amount of time an operator needs to spend in these chemical storage areas. All mechanical equipment, fasteners, and connections should be constructed of a non-ferrous metal, any metal that contains iron. Alternatively, you could epoxy coat stainless steel. So we want to make sure that those systems aren't rusting or corroding and falling off the walls. It's just going to put you in a situation again where you're spending more time in that space. Fun fact, silver and gold, while they probably fall in the sexier side of the mechanical system design, are non-ferrous metals. So if you have the budget and can get them, those could be included. A plumbed safety eye wash station, typical to the one that you would see, in a high school chemistry classroom with the overhead showers, is ideal for these spaces. There are also handheld units that you can just buy off the shelf and place them in your chemical treatment rooms. But ideally, those are there's one of those showers included in each of the rooms. And I'm going to talk about those different rooms here momentarily. But you shouldn't really need to be using a safety eye wash station if you are properly utilizing PPE, such as safety goggles, a thick apron, and gloves. At least one set of those equipment should be included in one of your mechanical or water chemistry treatment rooms. I realize that the gloves might be difficult to handle and work or maintain some of these pumps, so that can be a challenge, but it is certainly well worth it over having acid burn your hands. So if you could go to the next slide. Should be. There we go. So talking about how we keep these chemical treatment systems separated, and a new design preferably we would separate the systems based on one primary sanitation room and one pH buffer room. So either your liquid or solid chlorine rooms, or we might be looking at a different type of system, but typically that's what we're going to see. And then your pH buffer rooms, so either muriatic acid, CO2, or one of the other alternatives that I'll talk about here in a second. Your bulk storage tanks should include some type of secondary containment. So that might be in the form of a spill platform, or for larger storage tanks that you would use for sodium hypochlorite, liquid chlorine, you might place those in a double wall chlorine tank. That's going to just prevent any major spills, from occurring if one of the fail safes were to fail. Looking at, going back to the safety eye wash shower that I mentioned, a lot of times if you include that that space or that shower in the space, you would need to also include a floor drain. So spill platforms or double wall tanks are going to eliminate the possibility of chemicals spilling over into that floor drain and going to storm or somewhere they shouldn't be. If we can't get to dedicated chemical storage rooms, we want to isolate muriatic acid at all costs if it's being used at your facility. So that might come in the form of feed pumps being placed or mounted in the main mechanical space. And then we're running chemical tubing through the walls to isolate the storage carboys in either a separate space or exterior of the building if you live in a more temperate climate. Muriatic acid should always be stored away from alkaline material, oxidizing agents, such as some of your chlorine materials and base metals, because they can cause hydrogen generation. And as Bob already mentioned, if we're mixing muriatic acid and an oxidizer, whether it be sodium or calcium hypochlorite, that could lead to the generation of chlorine gas, which is deadly in certain doses, so not preferred and wanted to be avoided at all costs. And finally, there are new systems on the market for solid acid sodium bisulfate feed systems, which have been gaining traction in the industry. We've seen them used successfully at a number of facilities. Those are typically proprietary in nature. So the biggest complaint we get is that the cost of the sodium bisulfate tablets, which have to be purchased directly through a distributor or the manufacturer themselves, is can become costly, particularly for outdoor pools that have a lot of sun exposure. But the main benefit of them is that they have significantly reduced off-gassing, which corrode and cause a danger to operators. So from a on reliability side, I think they're very much preferred from that standpoint. And that's the reason that we see them being installed in more and more facilities. Next slide, Dewey. So here's an example of, and I apologize if this is your facility. I've got a couple other photos of where, examples to explain some of the slides. So here we have a facility that was being renovated. It looks much cleaner at this point, but you can see on the left side, there are standard pumps that were installed on the in the main mechanical space. And at one point they had acid carboys stored directly adjacent, but that was corroding the adjacent panels, the pumps themselves. There's a recirculation pump. You can see right there that was being eaten up, and it's evident from the walls, the rust that's been dripping down from the fixtures above. So they ran chemical tubing through the CMU walls to the exterior of the building. On the right side, you can see the housing that was built, which is not ideal because it's constructed of some of those ferrous metals we were talking about, which will oxidize and corrode. But it's better than keeping them in the main space because now they are passively ventilated by the surrounding environment. So if you can build a small shelter or hut, that can be gated off, that can work. But again, this is a renovation and would be a preferred approach for new construction. Next slide, please. So I put expected quantities of chemicals to be stored. Perhaps Lloyd will get into some of this in his discussion, but I bring this up to point out a couple things. One, fortunately, we aren't working with chemicals that could be deemed lethal on the health hazard scale. So everything is going to be a 3 at maximum for your calcium hypochlorite, muriatic acids of the world, which are, of course, dangerous to handle, should be handled with extreme caution, but aren't going to kill you in a small dose. So that's encouraging, but again, not ideal overall. We are still dealing with chemicals, which is why they have to be treated with care. And we want to again going back, I keep saying it, but we want to minimize the amount of time that you work inside a chemical treatment room. So I also bring up this slide to show you that you might expect to see 300 gallons per week of sodium hypochlorite demand, or 200 pounds of calcium hypochlorite demand. Calcium hypochlorite are classified as class 3 oxidizers, which the International Building Code limits you to the amount that you could store in a space with or without fire suppression. So oftentimes it's a balancing act to figure out, okay, how much can we store in our space by code, and how much are we expecting to use every week? Next slide, please. So air handling, your exhaust systems, we want to make sure that separate exhaust systems are used. Again, we've mentioned it a couple times here, but if we have a potential to combine gas from calcium hypochlorite and sodium hypochlorite and muriatic acid, we don't want to be creating chlorine gas. So those rooms should be exhausted by separate systems, separate fans. And those exhaust ducts should run directly to the exterior of the building. So we don't want them collecting any other exhausts that could potentially, again, combine and cause some sort of caustic reaction. Typically, code requires chemical treatment rooms be ventilated at a minimum of 1 CFM per square foot of the floor space in one of those rooms, or 10 air changes per hour, whichever is faster. So there's a couple of different ways that you can approach this, but we always suggest that the exhaust ducts be placed as low as possible in the room. And I'll have an example of this here shortly, because we know that chemically laden air tends to settle towards the bottom or the lowest point of a space. So we want to be drawing our exhaust from as low as possible. You always want to make sure to, I can't tell you how many times I've walked into a muriatic acid or pH buffer room and seen the fume scrubbers and vapor shields disconnected because the carboy was just swapped and the chemical tubing was just placed back into it. And at that point, you are releasing the off-gassing of the muriatic acid into the space, which is not preferred. But you're also, just not getting the benefit of the fume scrubbers. So always make sure to reconnect that and prevent deterioration of your space. Finally, we could go with a passively ventilated option if the budget does not allow for a fully enclosed space. This approach is taken a lot in Texas, where I live, because there's not a huge concern with freezing and thaw conditions. So this is effective, but not preferred, because you can't control the amount of air changes or recirculation of the air in the space. You're just relying on the surrounding environment. Next slide. So here I've got an example of exhausting from low in the space, and a facility where at first they were not using a non-ferrous metal ductwork. You can see it was corroding. All the fasteners were deteriorating within a few months of this facility operating. So it was leaching on the ground onto the floor. So they made the decision to replace it with a prefabricated ductwork on the right. You can see in blue, which is encased and does not have any potential to rust and corrode. So it doesn't have to be that complicated. We're just taking an exhaust duct to the floor, but that is going to significantly help the lifespan of these chemical treatment rooms. Next slide, please. And just a couple poor chemical room designs that I've seen. This facility was the mechanical space was in a basement, which actually flooded at one point, so things were moved around. But you can see the main mechanical space is what you're looking at on the left side, and then the CMU brick blocks enclosed what was the pH buffer room. So muriatic acid fumes were essentially being pumped from the that room out into the main mechanical space. There were stairs above, so it was just not an ideal situation where you've got your pH buffer room essentially sharing the same air as the main mechanical space. And then next slide, please. This is probably one of the worst setups I'd seen, where you had muriatic acid carboys directly adjacent to your liquid chlorine bulk storage tank, which was then closed in a very tight room. And it oftentimes wasn't even completely closed. So you can see that the door handle was deteriorated to failure, and the overhead ductwork was completely shot. Not a safe room, and one that we suggested be essentially condemned and replaced in its entirety. And that should be it from my end. Thank you, everyone.
Hey, thank y'all. I'm going to very quickly just go back to the very beginning slide just as a placeholder. So I apologize for the flow there. We had a little bit of a technical issue with our presentation. So the presentation from Lloyd Munn is not available. We will send that out probably tomorrow. If not, it'll be by Monday to all attendees to where you have the full set of presentations. I'd like to turn it over to Lloyd Munn with Cadence Insurance, who is an OSHA safety and compliance specialist. Lloyd, the floor is all yours.
Well, thank you very much. The PowerPoint that's going to be sent out, first and foremost, is a very good tool if you're having to do training and bring everybody up to date on hazard communication or the global harmonization. As Dewey said, I deal quite a bit with OSHA and many clients that run into problems with OSHA. So all of my conversations today really relates to chemical safety and hazard communication as it applies to OSHA. On average, I do a mitigation a week. So I do 50 to 70 mitigations a year. And I can tell you from that OSHA cites the hazard communication standard quite a bit. So a little history here. Hazard communication has been around for quite a long time, but several years ago, they upgraded it. So when an OSHA compliance officer comes out and sees an employee, and if you're building a pool or doing construction or that sort of thing, they will ask them, do you have a hazard communication program? Do you have a right to know program? Do you have a global harmonization program? And these are all the same thing. We took the old hazard communication program for material safety data sheets that had all the information on a chemical. And when they made their improvement to it and called it global harmonization system, they changed it to just safety data sheets, took the material away from it, and made it a standardized type of flow. So no longer when you got a chemical or a drum of chemicals in, it didn't look like an advertisement from DuPont, 3M, whoever it is. It followed the same format and the sections on it. So if you wanted to know first aid for a particular chemical, then you could go to section 4 and you could find it. And they made all the labels the same and that sort of thing. There's a few things that I would like you to take away from my short conversation today. First and foremost, it is about employee safety and the employee's right to look up something that could be potentially harmful. Now, we use in our world, in construction, we use a lot of chemicals that are dangerous. And my best example of that is gasoline. Gasoline is very explosive. It's harmful. but almost no one on this call has ever had training on gasoline. And it's because the way we use it. And that is the way it is with about 98% of the chemicals that employees touch. But if all of a sudden somebody develops a rash or they have a concern about it, the employee has the right to know about it. Now, we can use these same safety data sheets to help our safety, to look up what type respirator we might need, or to make good decisions when handling these. But first and foremost, it is about employee safety and the employee having the right and the ability to go get the information if they have a concern about things. Now, the old system that we looked at for years was a very antiquated system. It was a little tag that was either a diamond or a rectangle that was red, yellow, blue, and white, and with a numerical system of 1 through 4. So if you had something like gasoline, it had a 4 on it. It didn't tell you a whole lot. And one of the things that I like about the new system is it makes it better. Everybody's singing off the same page, so to speak. What they did was they said all manufacturers will have to use the same labeling system. All manufacturers now use a pictogram system that's in the PowerPoint that will be sent out that explains each one. So now you can look at a drum of chemicals or something and see a skull and crossbone or exclamation point or something that's corrosive. And the old saying, a picture tells 1,000 words. It's very, very true. Then they can look at it and say, okay, do I need to look at something that's a little closer? Do I need to test this? Am I in a room with, very poor ventilation? And do I need to take extra precautions? And at what point is something, could be possibly dangerous? Now, I'm really speaking to those folks that are out there using chemicals, not the retail space that's generally taken care of very well with the labeling and things that go on. But I get the question all the time, what do I have to keep up with? And the answer is, quite frankly, whatever you use. From dealing with OSHA, sometimes almost on a daily basis, you find that if you speak to 5 different compliance officers, you get 5 different answers. I love the safety rules that OSHA has, but I don't always like the way they apply it because I don't see a very standardized thing, and I cover multiple states in my travels. So if you're a pool contractor and you're out using adhesives and things that are in your van or in your work truck, then those are the things that we need to make sure that we have a list of and have the safety data sheets for it. Now, the next question I get all the time, do I have to have it with me 24/7? And the answer is, it really depends. The language within OSHA says that it is accessible, and things have changed in our world. We now use tablets and phones and things to look things up. There's a lot of companies that use a database for their safety data sheets. But at a minimum, we should make an inventory list of those things that we use. And some of those safety data sheets are actually on the product itself. WD-40 is a good example of that. I get the question, what about the safety data sheet? Well, it's printed on the can. The other thing that we would keep in mind that is what I call low-hanging fruit when it comes to OSHA is their ability to give a citation for secondary containers. Like the last presenter or presenter said, if you didn't hear anything else, hear this. If you don't hear anything else that I say in my couple of minutes, hear this. If you take something out of an original container and you put it in a secondary container, it needs to be labeled. Whether that's with one of these stickers, whether that's with a Sharpie, but I see citations in excess of $10,000, $20,000 for chemicals that are put in pump-up sprayers, that are put in water bottles. So if you take something out of an original container, and there are rules kind of down in the weeds, if you're going to use it within 8 hours, or, there's some exceptions there, but I try not to give people the exceptions. I try to say, if you're going to take it out of original container, label it, because you're guilty. And we need to, and we use the same chemicals over and over again, and we need to make sure that we're doing. And in some cases, we have to test things. If we have to test, then we need to just do that test. Of course, I'm an old guy, so back in the old days, you had to have multiple ways to test things, toxic, for flammable. These days, we have multimeters, and they're easy to rent, they're easy to buy, and they're easy to read. But if we're going to be using them, we need to make sure that our people understand it and understand permissible limits, because there's all sorts of chemicals and limits out there. The question becomes, when does it become dangerous? The other thing I will tell you is a little story. I was traveling in Mississippi and stopped in a small convenience store to get some gasoline and something to drink and go to the restroom. And when I stepped in the restroom, I was overcome. Chemical smell, my eyes were watering, I almost passed out. And this happened to be one of our clients. And so I went to the nice lady at the register and I said, there's a problem in the bathroom. And she did not want to talk to me. So I picked up the phone, I called the owner of this convenience store chain. And I explained to him that there was a problem. Well, what had happened was one person was cleaning with one product, somebody or either ran out and cleaned with another product, and we had a chemical reaction. And I explained to the clerk, what if that had been a mom with a little boy and said, go in there, go to the restroom, lock the door, wash your hands. By the time we would have figured out there was a problem, that child would have been dead. So I make it very, very clear when I do my training and I'm out with contractors and such, that everybody has a different background when it comes to chemicals and how they react and how they do. So sometimes we have to go that extra mile to kind of figure things out. And we also have to kind of watch out for our coworkers out there, because people have a different background with it and knowledge of things there. So, look out for your coworkers. Don't let them use the old school method of sniffing a chemical or taking something for granted that it is okay. The other thing is that labeling will look pretty much the same way on everything that you get moving forward. Whether you get a chemical from Europe, Mexico, Canada, or from down the street, all our labels are going to pretty much look the same these days. It's either going to be portrait or landscape. It's going to have the chemical on it, the product name, a signal pictogram or multiple pictograms. It's going to have a signal word, whether it's warning, dangerous, how to handle it. And at the bottom of it, it will always have where the chemical came from. So you can always contact the manufacturer if you have a problem or you're having a problem getting the material safety data sheet on it. I cannot stress enough that in every year we keep up with the top 20 things that OSHA cites contractors and businesses on. And every year it is hazard communication, right to know, or global harmonization system. It's all the same. It's always in the top 20. Every time it seems that we have an inspection by a compliance officer, that question is always going to be asked. So I would employ you to train your people to be able to answer their questions, to know that hazard communication, global harmonization, or right to know are the exact same things, because different compliance officers will ask them different ways, even though you have one, and that they can understand and respond properly to it. You know, it's kind of a moving target, but also keep in mind, like I said before, it is about the employees' right to know about things, even though the company is brought in and tasked with identifying some of these. Don't take for granted that you're not going to get asked about it, because if you see an OSHA compliance officer, there's about a 99% chance that he's going to ask that question: do you have a right to know hazard communication? And it is completely different from shipping labels and DOT. It is its own entity. It's its own set of rules that go along with it. I'm coming up on the end of my time, and so I'm going to recap with this. Train your people. They're sending around a PowerPoint that's a very good and basic way of saying, here was the old system, here's the new system, here's what it looks like. Feel free to contact me to send you additional resources. I'll be glad to do it. Test, do your simple inventories of your crew trucks and that sort of thing. And if you put something in a secondary container, it needs to be labeled. I cannot stress that strongly enough. Thank y'all very much for allowing me to talk on this. This is something that we usually spend about an hour and a half on in training. It's very condensed. Dewey has my contact information. That's Susan and Jill. And I'll be glad to send out resources to anybody. I'm a OSHA trainer. I've been doing it for years, even though I work for a insurance agency. I've been a OSHA OTC trainer for years and have lots and lots of resources that I have borrowed from people through the years, and I'll be glad to share them. Thank you very much for letting me share a few minutes with y'all. Thank y'all.
Great. Thank you, Lloyd. Thank you. So I want to stop screen sharing right now. And we have some questions that have come in that we're going to address very quickly. So the first question coming in is for Bob, right? And this may be more of an opinion item, but does the MAC adequately address some of the recommendations you made?
And I think that's a great question to ask, Dewey. And I guess what I'd like to do is, I know that you're very current on interlocking, and you feel the same way I do too about how critical it is to have good interlocks in your system. What are your thoughts on it? Because I think you're closer to the MAC than I am.
Yeah, the MAC has a couple of different areas in it, and primarily it's the performance testing, right? Which is in the MAC, it's required to be done monthly. Documented performance testing, as well as the presence of interlocks, right? Now the MAC does go one step further and requires both a flow switch and also an electrical interlock. Now, there are some good questions that Bob has brought up on the more modern approach to chemical controllers. When the MAC was first developed and first written, we didn't have as finessed of a controller as we do now. So there might be some room for improvement there, in a future change request. But the MAC does require 30-day, performance testing every 30 days, and then at least two forms of interlocks, one being a flow switch, and then the other being electrical. So we have another kind of question. This is kind of interesting, right? So I'll just kind of read the question, right? When I was a kid about 40 years ago, I inhaled some chlorine gas, had a bad reaction, called 911, and the operator said to drink water with salt in it, which I've never heard of in this instance, right? Does any of our panelists have any idea what that could have been about?
So Dewey, just Bob Kappel here, just jumping in. I'm a retired firefighter, and I've never heard of that before. And let's just consider, I'm not a medical professional, obviously, first responder, but we were trained on chlorine gas, and chlorine gas will go through the bunkers and come in contact with the skin. Now, the problem with chlorine gas is chlorine gas doesn't have a pH until it mixes with water. So when chlorine gas encounters something wet, whether it be H2O, sweat, saliva, moisture in the lungs, it not only oxidizes the surface, it basically makes two different acids. It makes hydrochloric acid and hypochlorous acid, which oxidizes, but the acids are damaging to moist tissues. So problem with chlorine gas is inhalation and damaging the lungs, the throat, the sinuses. And that's where the problem comes in, because it interferes with your respiration and not only chemical burns on your skin. So the consuming salt water, I'm not quite sure. I've never heard of that before, and I'm not quite sure what that is. I'm not saying it's invalid, but it's not logical to me.
Yeah, I've been in the first aid world for a long time, and I've never heard that one either. So it's kind of interesting. There may be more to it, but I tell you what, I'm definitely going to put that on my list to reach out to a couple of medical professionals I know and see what their thoughts are. So very, very interesting. I do want to share one comment, just as a reminder made by one of our attendees, right? And it's one of these little small nuance things, right? But always remember, test your interlocks when the pool is not closed, when the pool is closed. You don't want anyone in the pool in case the interlock fails. And plus the interlock may be, and just adding to that comment too, right? In your performance testing, this may require power to be turned off the pump system temporarily. And of course, that's an imminent hazard that we see where the pool would need to be closed anyway. So, just kind of a good maintenance reminder, right? So that might be something good to do when the pool is closed, when there's no other activity, when you're doing some of these other maintenance items. If you have a closure day where you do your major maintenance, that's a really good time to do it. Or as a reminder, the MAC requires that the pool is closed during backwashing. So that might be a good time to test your interlocks there as well. So very, very good. Lloyd, I've got one follow-up question for you on training.
Okay.
Just for our audience, right? We have a lot of folks, and there's a lot of pools out there, and some are year-round, some are seasonal. We have a lot of public health officials on the call today. And we've had some discussion of this in the past, right? What does OSHA require as far as training frequency for hazardous chemicals?
There's really not a requirement other than you should be trained. They use terms like adequately trained. Just about every discipline that you will have with OSHA, they will say, shall be adequately trained. They never tell you how to do, just that you've got to do. So there's not a regiment spelled out in OSHA that I'm aware of that says, if you handle these sorts of chemicals and so on and so forth, you have to meet these minimum requirements. It's more of a generality type expression from OSHA. This can be done online. This can be done in person. I employ everybody to, have some sort of standardized training and list of things, whether it's forklift, aerial lift, those things that people do to put within their training regiment. And because it is so asked and so cited within OSHA, it would make sense to make sure that GHS is one of those topics that we cover. And to add to that, I would say most of the citations that I see comes from an employee that does not know how to answer the question, even though the company has come within their manual and has everything. They just become very confused because it's not something that people talk about all the time. It's just something we do. And then when it's put to them in a quick interview on a job site, they don't answer it correctly. And we're usually in informal conferences and negotiations and that sort of thing. I know that was a long-winded answer and not really answering your question, but there's not really I can't go to a sentence in the OSHA book and say, this is what they say to do. That's just not the way their regs are written.
Is there a particular training frequency? I know there's been some debate on this in certain circles. What does OSHA say on training frequency, Lloyd?
Well, most of those will fall under what we call best practices. Okay. I'll give you a quick example. You can take OSHA 10-hour class and it's good forever. And then you will go onto a job site and they will say, you need to do this every 3 years because things change. So OSHA doesn't say things are wrong after a certain amount of time, but in certain issues like forklifts and such, as part of best practices, they would suggest that you do it every 3 years, even though there's not a requirement. Keep in mind, OSHA rules are written two different ways. It will say shall, will, or must. That means you've got to do it, or it may say could, should, or may. So typically things that we're talking about as far as refresher training and such, the language within OSHA will say could, should, or may, which are what we call best practices and not necessarily mandatory within the OSHA regulations out there. If you have a kind of a standard type program out there that you're doing, my rule of thumb is 3 years on everything. But there's not a set OSHA regulation that says all training has to be refreshed in 3 years. Some is done through associations. If you're a traffic control specialist, if you are a flagger trainer, or those sorts of things will have renewals on them. Or if you do torch down application for roofs, you have to do them every 3 years, but that's a requirement of that association that puts on the training and not necessarily OSHA. That's the best
Great,
answer.
thank you, Lloyd.
Yeah.
Great, thank you. Just as a reminder, if you have any more questions, please throw them in the chat. We're 11:12. We're going to be finishing in just a minute. But we'd like to make sure we have all of your questions answered. While we're waiting for any final questions to come in, again, we want to thank our panelists and our speakers today for taking some time out to be with us and sharing your expertise. I would like to kind of give an advance promotion. Our June webinar is going to be on splash pads and splash pad safety. That one is currently scheduled for June 1st at 11 a.m. Eastern. As part of that webinar, in addition to talking about general splash pad requirements and having questions answered, we're going to have an incident kind of debrief, so to speak, right? Where we're talking about an incident that unfortunately resulted in illness and subsequent death at a facility. So put that one on your radar. That one's going to be a very extremely interesting webinar that we're very looking forward to. So look for that advertisement, that registration will be coming out in May. So with that being said, we don't see any more questions in our chat. I know everyone's got a very busy day ahead of them. So I want to thank everyone for coming. Thank you for your time. To our public health officials, thank you for the work that you're doing to be our lifeguards for our aquatics professionals and being their second eyes and ears to keep people safe, especially from these chemical related injuries. To our operators, thank you for the work you're doing and let's have a target of 0 chemical injuries for 2023. How about that? Let's shoot for that one, right? So again, thank y'all very much. Thank you for our panelists again. Thank you for our attendees. And we look forward to seeing you in our next webinar in June. Thank y'all.